All right, we are live. So welcome everyone to Science Saturday. Looks like Kitty, you've got everyone in the shot there.
Got everyone in the shot.
So I'll toss it over to you. I just say that I'm really excited about this one just because it's one of my favorites. I wish I could be there in the field, so I'm just pretending with Sonora right behind me. But I'll throw it to you. What are you guys doing this Science Saturday?
Hey, good morning, everybody, and welcome to our February Science Saturday. This month, we are talking all about the science behind coral disease. And, the stony coral tissue loss disease is a really serious threat to the territory, and we have a ton of teams out there learning about it, trying to fix it, trying to help our coral reefs. And I am joined today by a mask that won't stay on my nose. But more importantly, I am joined today by Sonora. Hey, Sonora, do you want to introduce yourself?
Good morning, everyone. I'm Sonora, as Kitty said, and I'm the marine disease specialist here at the University of the Virgin Islands, which means I just study coral disease. And there's a lovely picture of me that Joe took. I'm simultaneously here with everyone and surveying diseased coral in the water.
I like that. The multitasking is amazing. And of course, we are joined by our favorite Science Saturday intern, Mason. Heyo. And a special shout out today. This is going to be really exciting. That creeper over my shoulder. Hey, we have some really cool 3D printed coral models that we're going to be using today. And Jarvon printed those and hand painted them and is going to be hanging out with us to see his amazing work live being surveyed. So, as always, I want to thank everybody for joining in, those of you who are watching later on the recorded version. So let's get started. Joe, what are we talking about?
Thanks, Kitty. Yeah, so I think as we've mentioned, we're going to be getting into coral disease. And so I thought it'd be a good time to just talk a little bit about this specific coral disease that we've been studying most recently. Sonora, Kitty, and I have actually been collectively working on understanding this disease for almost 2 years now, or a little bit over 2 years now. And so I thought it might be a good idea, maybe if Sonora, you want to just talk a little bit about the disease. I'm just going to put up some of the photos that you've taken on some of our surveys and studies. So we're talking about a specific disease, right? Stony coral tissue loss disease.
Yeah, so just to kind of bounce off of that, there are a lot of different diseases that corals can get. And I want to remind everyone that corals are actually animals. It's usually thought that they're not, but they are. They're really closely related to anemones and to jellyfish. And corals are actually made up of a lot of tiny little clones that look like tiny anemones, which Siobhan actually has a little model of we're going to show you. So this is
that's the cutest thing in the world.
Usually they're a lot smaller than this, but you can see they have little tentacles and they look like tiny anemones. And what coral colonies are, which are what you see when you go snorkeling, is a whole bunch of these all next to each other, and they're all little clones of each other. And just to get back to the disease, like all other animals, corals can get diseases. They can get sick. And the disease we're talking about today is stony coral tissue loss disease, which has been around for about 6 years in Florida and the Caribbean, but it's only been here in the Virgin Islands for 2 years, like Joe just mentioned, that all of us have been working to kind of figure out how this new disease is affecting the corals and how it's changing our reefs.
So I think maybe to start off, what kind of indicates that what happens when the corals catch this disease?
Yeah, so we don't fully understand this disease yet, but on a visual level, we know that corals are diseased whenever they develop what are called lesions. So this is whenever they start to die and their tissue kind of starts falling off of their skeletons. So Joe's going to put up probably a nice picture of this. Yeah. So where you can see his cursor is that white area. This is the skeleton of the coral. So they're animals like us, and they have bones and they have tissue that's living on top of that bone. But in that white area, the tissue has actually died. So you're seeing the actual bone of the coral. And the orange area on the right, that's where the coral is still living. And it's actually colored because there's a lot of tiny little algae that live inside of the coral that help give it food.
Right. I've got a couple other photos here. I could just kind of go through a couple of them here, just to see kind of what that disease looks like on other species as well.
Yeah, so what's unique about this disease compared to other diseases that the corals get is that sometimes they have multiple lesions, or this one you see the lesion is in the middle of the coral. It's not on the edge, which a lot of coral diseases start on the edge and they only have one lesion.
Oh, there we go. There's some nice close-ups that you took, correct? These are yours?
Yep.
Get a
So
good
if
idea
you
of
see
that.
all those tiny little circles everywhere, those are the polyps I was talking about, which was that model that I showed you guys. And each of those are all clones of each other to make the big coral colony.
Very cool. Well, very interesting, I should say.
Yeah, not cool for the corals.
I'll just right. We do have one comment on here. Susan Edwards says, "Hi, Mason." Just wanted to make sure everyone knew that.
Hey, Grahamsy.
Just but yes, I mean, so this is something really, and so over time, we'll kind of see this white area slowly expand as that kind of that healthy or that colored tissue slowly dies off until we have just a completely bare skeleton, and that's a dead colony, right? That's a dead coral.
Yep. So, like Kitty mentioned, this is a really bad disease, and it's all over St. Thomas and St. John now, and it recently made it to St. Croix and is slowly working its way around their reefs. This is an example of one that has multiple lesions. But this disease is changing our reefs significantly and very quickly because, like Joe said, a lot of these corals are dying really fast. And we know reefs are super important because the fish like to live on them and they like to eat food on them. They like to hide inside the reefs. But also we like to go snorkeling and scuba diving and look at the corals. So reefs are super important. So one of the things that I work on is studying how this disease is changing our reefs and how it affects certain species of corals and how we can hopefully stop this disease and help the corals. So now we have a little demonstration of one of the surveys that we do on the reef. So,
all right, so we're getting into the real science of how the researchers like Sonora at the university learn about this coral disease. So I'm going to flip over so that we can watch them. And Sonora and Mason are going to go diving on this beautiful but possibly diseased coral reef that Jarvan made.
Yep. So here's our reef. What we do whenever we're scuba diving, we usually have teams of 2. So today I'll be diving with Mason.
Heyo.
And what we do is on the reef, we mark corals with tags so that we can find the coral whenever we go diving at another time. And we can check up on all these corals later. So once we go diving, we find this coral and we're going to put usually some kind of weight down next to it. And then Mason, my helper, has a giant ruler that we call a transect tape that we use to measure things underwater. And for these surveys, we survey all the corals in a big circle around this one coral to see how they're doing and check if they're diseased and if they're not, if they're still living or if they died. So we're going to start swimming around our reef and we can look at what's happening.
All right, awesome. Ready to do a survey.
All right, Mason, you lead the way.
Before we get started, I think, could you guys just show us some of the corals that we're looking with? These are what Jarvan worked on, right? Can we get a closer look at some of these?
Yeah, we're going to get a closer look at each one. So this is our first coral that we're encountering.
And this is a branching coral, which we call a Acropora palmata, or a staghorn coral. What's special about these corals with this disease is that they don't get sick. So even if all the other corals on the reef are getting sick, all of these types of corals are doing great.
That's good. It's nice to see some standouts. So on our data sheet, we would be like, this is an acropora and he is A-okay.
And then we would,
That's the scientific term.
right, that's what I write down on my data sheet. And then we would swim to the next coral.
We're swimming.
Can you guys tell us what's the purpose of the transect tape? Why you've attached it next to the central coral, right?
Yep, we attach it next to the central coral, and we're swimming around in a big circle. And having that marked coral and using this tape lets us check on the same corals every time we come back. And it also lets us see how far away the corals are from the middle coral, which we can run some computer models and statistics to see how disease is spaced out on the reef and see if corals are infecting each other or if it's just disease that's in the water that's making them sick.
Yeah, so Sonora, we're getting a little bit of wind noise, but what I heard was, we can use the transect tape so that we're finding the same corals every time, and as well, using some computer models and statistics, actually look at if there's a reason, corals are getting sick and more close together, or if it's kind of more spread out, and that's how you're able to measure that distance.
Yep.
Is that right?
You got it. We'll try to hang out a little closer together.
Dive buddies always stick together.
So we swam to our next coral now, and we have it down here on the reef. And this is our first coral. It's a brain coral that we found with a lesion. So that's this white area here you saw in the photos. And what we would do is we would take notes on our data sheet about which species it is, how many lesions it has, and how much has died. So I would say that this is about 35 or 40% mortality. And that's really important because next time we come back, we're going to see if more of the coral has died. So if the lesion has grown, or we call it progressed, and we can see how this coral is doing or if it recovers. And then we can swim to our next coral.
All right. There's Smush swimming.
Yep.
Mason, sorry.
This is a very important job, is having someone hold the transect. It's very helpful in the water. Okay. So here we have a small thicket of another species of branching corals, which are the elkhorn corals. Sorry, I don't know the common names. And just like the other branching species, they don't get this coral disease. They get other diseases, but sconitortal tissue loss disease does not affect these. So again, we're going to write on our data sheet that these are A-okay, they're happy, and we can move on to the next coral. So over here, we found another coral, and that one looks pretty good. I don't see any lesions on it. And what's important about this is that this species actually can get stony coral tissue loss disease, but this one doesn't have it. That could be because the disease just got to the reef, and this is not a very, what we call susceptible species. So they are stronger coral species, and they don't get it as easily. Or it could just be a very strong individual within that species.
So that individual could have a really good immune system, or
yeah. So it's kind of like sometimes maybe you get sick, but your brother or sister doesn't get sick, even though you're in the same area and you're the same, pretty close genetically because you're related.
All right.
So that might be a super coral.
Super coral. Woo.
Again, A-okay.
It needs a cape.
On.
Yeah, we'll get him a cape. All right, swimming along.
Over here, we found another one of those branching corals. Again, the Cervicornis. What's that one?
Oh, Cervicornis is staghorn?
Staghorn. Yes, staghorn coral. And this one has died.
Oh, no.
Because it's all white and we can see just the skeleton. But if you remember, this coral doesn't get stony coral tissue loss disease, so it probably died from something else. From maybe some other disease that this species can get, or bleaching, which which is what happens whenever the water gets too warm. The little algae leave the coral because it's stressed, and sometimes the coral dies from that because it can't get food. Or
Now, Sonora, coral bleaching is something I think a lot of people have heard about in the past, but that is different from stony coral tissue loss disease, right?
correct.
Is it so?
Bleached and white. That's
There we go.
because you're seeing the skeleton through the tissue, and the coral isn't actually dead whenever it's bleached. The coral can get those little algae back and be healthy again later. Ready to swim to the next coral?
All right, I think we're frozen, but just in case you guys can still hear us, we're still swimming. We're still frozen, so I assume that Joe is talking.
All right.
So I'm just gonna.
No, we're not frozen. You guys keep going. Sorry, I was just listening intently. We did have another shout out. Bumpy did want to offer a hello this morning.
Oh, hello, Bumpy.
Popular.
But what have we? But what have we got down here?
So here we have another brain coral, and if you remember, this species can get stony coral tissue loss disease, and it's all white. So we're seeing the skeleton again because it's completely died. So we're going to write that down in the data sheet.
I would just like to point out artistically that Javon did such an amazing job on these models, and that is beautiful.
Right, we normally wouldn't want to touch a coral, but can you pick that up and get a nice close shot of it so we can really see this? So these were printed using three-dimensional printing technology, right?
Yeah.
Yeah, they were.
Yes. That is
So-
so pretty. And Javon, where did you get the designs for this?
So some of these designs,
You want to hold it?
some of these designs are readily available on the internet. There's a website I use called Thingiverse, and so it's a platform where anyone who 3D models stuff can upload it for anyone around the world to use. And so the models for the brain coral and the branching coral I found online, but the models for the polyp and the Montastria, which we've seen already, those are coral that I designed myself.
What? Found it.
Very cool. We've got another shout out from Hazel and Liam, and everyone is saying that they love the coral models. So
So
keep them coming.
cool.
Really incredible technology, so that we can bring the corals that that we see all the time in the water onto shore and see really get an idea of what they look like. We'd never be able to handle real corals like this.
No.
So this is a really great way for us to get an idea of what this is like.
All right. So I think we're coming to the end of our disease wheel. This is our last coral in our wheel.
Yeah.
What do we got?
So here we have another coral with a lesion. If you remember, we saw this coral earlier, the same species, and that was our super coral that didn't have disease yet. So that kind of shows you that it is susceptible to the disease, and that maybe not all of them are as strong as each other. And that's super important to us to figure out which ones are super strong so we can help make more of those or help them continue to be strong so we can have stronger reef communities as a whole. But also, it's important. Sorry, we're right next to the airport. It's also really important for us to know which species are getting the disease first and how many of them die from it, so we know which ones we need to give a lot of extra help to. So we have a lot of divers here that are actually going into the water and giving corals medicine. So they're putting antibiotics and a paste onto these lesions where the corals are sick to help them fight this disease and be a little bit stronger.
Very cool. All right. So I'm going to move into the shade for the sake of my phone. But Joe, what are we talking about next? So what happens after we do these disease wheels?
Well, I think I wanted to get a little bit more information about the disease wheels, and I have actually an example of Sonora. She's going to get to be in 3 places at once, seeing what one of these disease wheels looks like underwater. A couple more shout outs. Again, the coral models are a big hit over here in the Science Saturday audience. So great work with that. But just to get an idea, we have these coral disease wheels. We have these across the Northern Virgin Islands, right? And is there things that we can learn by placing these disease wheels in different places or things like that? And while you do that, I'm going to go ahead and get up a video that Sonora, I believe you and Dan took of you performing a disease wheel underwater.
I think I took this video myself, but let's see. But yeah, Joe was saying we set these up all around the island and we put them on certain reefs before the disease gets there so we can see what corals were there and how they were doing before the disease. And then once the disease gets there, we go back and revisit. Remember, I had that marked coral with that green tag, and we see how the corals are doing throughout time to see how it affects those different species and how we can identify the strong ones and which ones we need to give a lot of treatment to. And so, yep, there I am. This one, I didn't have a buddy to help me hold the tape, but the buddy was nearby making sure I was safe. But I just spin around in a lot of circles, taking notes on all those corals. It takes a long time, but it's very fun and gives us a lot of really important information.
Right, so I see that. Oh, go ahead.
Oh, I was going to say another aspect of this project is half of our locations around the island, we have what are called strike teams that go and visit them and treat the corals with antibiotics. And the other half, nobody does anything to help the corals with. So we can evaluate how helpful we are to the corals and see if we're actually making a difference.
Right. I know from the disease response side, that's really helpful for us so that we know that we're doing the most we can to help the corals and how we're helping the corals the best way. So this is really important information, and it's really great that we can get this information in real time thanks to Sonora's work and all the work that's at the university. And I'll also just note that it is a lot harder to do these wheels when you can't talk to each other, like Sonora and Mason just were as dive buddies, but Sonora's doing a great job here, checking every single coral moving around here with a couple fish friends hanging out. So I think with that, we can also talk a little bit more about another aspect of understanding this disease. And so what we've been talking about so far is, looking at the entire reef, how much disease is on the reef, what corals are being affected, not affected. But Sonora, you've done a lot of work looking at specific corals and how those specific corals are affected, right? Can you tell us a little bit about how you study that?
Yeah, so as we mentioned earlier, there are different corals that get sick at different times or that die faster than others. And we can pick that up with the disease wheels, but not on the single colony level, like Joe's talking about, looking at one individual coral. So what I did as a separate project is I visited individual corals every single week for 6 months. And I watched essentially how fast or slow they died, if the disease would stop progressing, so if the corals got better on their own, and compared that between different species of corals.
This is a real emotional roller coaster type of work to be done.
Yeah, it's definitely hard to go out and see all these corals dying. But to do that a little more rigorously or a little bit better than just taking notes on the corals like we do for the disease wheels, I actually built 3D models of the corals. So Mason's going to demonstrate how I would actually do that today. We're not going to go scuba diving to do this. We have a little toy that he's going to do a model of.
It's a nudie break.
When we go diving, we take these giant cameras with us that have a special box around them that make sure the cameras don't get wet or ruined. And then they have these long arms with these lights on them that we can turn on so that there's no shadows on the coral and so that everything looks good in the model and we can do a great assessment of how well the coral's doing. So
while we're getting this video, we do have a question from the audience. Liam would like to know where that disease wheel video was taken.
That was at Buck Island.
Buck Island, right here on St. Thomas. So that's a reef that we have a lot of people see from the South Shore. Thanks,
So-
Sonora.
Mason's doing a great job. What we would do whenever me and all the people, I'll wait for the plane again. What all the people that come and help me and I do is exactly what Mason's doing, is you would take a video going around the coral, circling it, making sure you get to see all of the coral in the video, going pretty slow.
You look very cool, Mason.
Yeah, you look super cool underwater doing this. And then once we've taken all of these videos, I use the computer to take pictures out of the video. And then I put them into a computer, and Joe's going to show you. Oh, after Kitty shows us the cute nudibranch.
It's adorable, right? Like, hello, I'm a nudibranch. Okay, serious.
Once we put it in the computer, I start building the 3D model, which Joe actually has some little pictures of.
Yeah, so like a cooking show. Normally we would take those videos that Mason just took, but Sonora actually went ahead and did this for us so that we can have the finished example. Sonora, would you like me to start with the final model, or did you want to start kind of earlier on in the steps?
Let's build it
We
up.
took-
Let's build that anticipation.
Okay, well, great. So I'll start with just the point cloud, if that. Okay, so we'll go to here. So this is the point cloud, right, Sonora?
Yes. So you can kind of see the nudibranch there already, but it's just a bunch of little dots arranged on the computer. So what the computer has done is it has looked at, I took about 300 photos out of the video, and it looked at all those photos and found places where there's the same thing in every photo. So it found the nudibranch's eyeball and a bunch of photos, and it put a little point here that we're seeing. There's another plane. So we can use those photos to figure out in 3D space what the model's going to look like. And then we can go to the next step, which is the dense point cloud. And this is where the computer uses those pictures, and it can tell how far away the camera was from the nudibranch. And it adds in what are called depth maps. So we start to get a 3-dimensional object. This one actually looks pretty good because I put in so many pictures. But if you look closely, it's still just millions of tiny little dots. We don't actually have a structure that maybe Javon could 3D print. So we have to do the next step, which connects all of those dots, which is called the mesh.
Ooh.
And you see, we lost all of our color, and that's just because it's drawing little lines essentially between all of the dots, so it's one solid object. And then we can put all of those pictures on top of this mesh so that we create what's called a textured mesh. And we have our full model. And it looks just like the little nudibranch that Mason took a video for us. And Joe, I think, has a little video, because you can spin this model around in 3-dimensional space.
Whoa.
I don't know what that yellow part is, but this is.
Yeah, let me get the better version. 1 second.
It's the halo of awesomeness around the floating nudibranch.
But it's really important for us to build these 3D models, because as you've seen, these corals, they're not very flat and they're pretty round. So it's really hard to look at the whole coral and see how it's doing and make measurements of how much has died using just a photo. So these 3D models help us a lot to really get a good picture about what's happening with the corals. So the nudibranch can fly around.
Yeah, these models are really incredible. It really looks like the actual object that we had in there, and so you can get a really good idea of everything that's going on that coral just from taking some video underwater and then analyzing it this way later, right? What are some of the
Yep.
things that you're able to pull out of this? I'll play that again for everyone to see.
So for corals, we're super interested in surface area, which is just how much of that tissue is living or dead. And then I can compare that between time points to see how fast they're dying, to see which corals species are stronger than others, and again, which ones we need to give more help to not die from this disease.
So I just want to point out really quickly, as we've been going through all of these demonstrations and the disease wheel, how many different things you have to know. Like, I'm always blown away with spatial relativity and numbers because, not my thing. But if we're looking at STEM and STEAM, actually, let's go with STEAM. So science, technology, engineering, arts, and math. Doing the disease wheels, we were working with spatial relations, how far apart the corals were. Sonora was able to look at the lesion and estimate the percentage of mortality on that coral. The actual building of the coral models, the physical models that Jervon did, combining art with the ones that he designed himself, and computer technology and programming to actually build those. And then this computer software to make the 3D model video is insane. And so I think that it's so cool to look at all the different disciplines and just how much goes into this is mind-boggling to me, which is why I'm holding the phone and everybody else is talking. But I think that it is wildly impressive and inspiring for anybody interested in a specific area of science or STEAM, and how individual strengths can really go towards the greater project, and some really, really cool research. So kudos, guys. You're so much smarter.
I agree completely, Kitty. I don't agree with that part, Kitty. But I agree. It's really incredible that we could use. I agree that we could use all this incredible technology to answer some really interesting questions about the reef, things that we never would have hoped to understand before without the use of all of these disciplines and all of this technology. So I think that's really incredible. I do have some of the models that Sonora that you've built of corals. I'm going to go ahead and get those pulled up, but in the meantime, could you maybe tell us a little bit about what you have found, like some of the things that you have discovered using these 3D models?
Yeah, so similar to how we know some species can get disease and some don't, I found that some species of coral die faster than others. So maybe, like Kitty was saying earlier, they're not as immune or not as strong to be able to fight off the disease as well. I also found that there's a role potentially of temperature in this disease. So we talked earlier about bleaching, and this is whenever the water gets really warm and the corals get stressed and their little algae leave. Usually this is a very stressful time and they get sick. But interestingly, with this disease, we found that a lot of the lesions from stony coral tissue loss disease actually slowed down whenever the water got warm and the corals got stressed. Or a lot of the lesions on one of the species actually stopped during this time.
My camera angle is way off.
We just get to look at my beautiful mask. But so the warm water, even though it's a very stressful time for the corals and a lot of them bleach, actually helps them to not have to fight off this disease as much during that few month time period.
Interesting.
Yeah, definitely really interesting. So I pulled up some of the models now. I'll start off with just I'll go ahead and share the screen again so you can see it. But yeah, understanding this disease, like Sonora said, has only been around for about 6, 7 years, and has only been here for about 2. So everything that we're learning about this disease is new and going straight into, learning more about what we can do about it, how we can, help, understand it a lot better. So I'll go ahead and share. So you guys seeing, so this is a copophilia, right? A boulder brain coral.
Yep.
I'll just play this.
So if you remember, I went out to the reef every week and built a model. So it's really cool because I can put them on top of each other and you can see how the lesions grow until the coral dies.
So this last photo in this time series, the coral is completely dead at that point, and it started off with just kind of a mark here in the middle.
Yep, because it's losing that colored area where it's living, and that white area is growing. And you see in the middle, it doesn't stay very white. It turns this grayish brown color, and that's because algae is starting to grow on where the coral has died on its skeleton.
Yeah, it's really easy to see on the model here, and I'll go to the next one in just a second. But that algae that Sonora's mentioning, then also this white all around it. This is what we were talking about earlier, where we know that there's no more tissue. So you can see that happening in real time, just changing. And these are what, a week apart, about?
I think so, yeah, for this coral. So you can see that it died very quickly in probably about a month or so. And this coral, for reference, is a little bit bigger than a basketball, maybe closer to like a beach ball size. So it's a pretty big coral that died very quickly.
So based on this type of coral, how old do you think that would be?
At least 50 years old. Ooh, between 50 and 100 years old, I'd say.
So 50 and 100 years old, growing, protecting our shorelines, providing homes for fish, and then with a fast-acting disease like this, dead in a month. That is terrifying.
Yeah, which just emphasizes how we really need to figure out a way to help these corals not die because they grow so slowly and die so quickly.
Yeah, that's scary. So those of you
I'll go ahead
follow
and go to the next
Saturday,
one.
we have talked about the benefits of coral reefs and the structure. 1 month, Joe and I were here looking at the shapes of the different corals, and this all comes together, and it's as if we had a plan to teach people and cross-reference our topics.
Just building up on the knowledge.
Yep. So what are we looking at now?
Yeah.
Just another species.
Oh, sorry, I forgot to make it loop.
So I did this for 6 different species on the reef. And for each species, I followed 5 different colonies. So every week, me and a dive buddy or a few dive buddies would go out and build models of 30 different corals on the reef. Wow. And watch them slowly get more and more sick.
So if anybody would like to support the Coral Research Program, we accept chocolate, gifts, emotional support, and funding.
Yeah, so in addition to those, I have to put in a little bit of a plug for the Coral Disease Advisory Committee. This is a wider group that Kitty and Sonora and I are a part of, that is comprehensively looking at this disease. And if you do want to learn more about that, I encourage you to check out vicoraldisease.org, which includes some of the research that we were talking about today, as well as some more information all about this disease, what we're doing to respond to it. So I'll make sure to include that into the comments, but if you haven't checked that out, that's vicoraldisease.org.
Yep, we've got a lot of information on there, but you know what we don't have is a 3D model of a nudibranch. And so for that quality content, you have to come to Science Saturday.
Absolutely. So one thing I noticed here, Sonora, the first 2 corals that we're looking at, these are they're both brain corals, right? So this is something that we've kind of learned as well, that brain corals are really heavily affected, right?
Yeah, they get sick very early on once the disease makes it to the reef, and then they die pretty quickly. And there aren't as many of those stronger individuals within those species. But I think what, Joe, you're about to get into is the Montassia cavernosa, which are a more stronger species of coral, even though they are still able to get sick from this disease.
So if you were to
Right, I think.
Oops, sorry. If you were to swim up on a reef that you had never done a survey on, from what I'm hearing is you could use these different species and your knowledge of how quickly they get sick to kind of see how long the disease had been there, right?
Correct. So there are a couple of species like the pillar coral that's in the background of Joe right there. That one, we know once that one gets sick, that's one of the first ones to get this disease. We know the disease just got there. And a lot of times, most or all of those are dead by the time the brain corals are starting to develop lesions. So like Kitty's saying, it kind of helps us determine how long the disease has been on the reef and how quickly it's spreading around the island.
All right, I think we've got one more. I'm gonna see. Yes, so this is the side-by-side ones, which I think is really cool too.
Yeah, so the first corals we were seeing, those were about a week apart, but these two corals, this is about a month apart, and you can see that the lesions have grown a lot and a lot of the coral has died, but there still is some living tissue on this coral because it is a little bit better at fighting off this disease than the brain corals.
Right. So I think that's all the models Sonora's provided for us today. I know she's built tons and tons of these models to really get a good idea of what's going on with these corals. But another thing that we have here, courtesy of Sonora for Science Saturday, not just one coral, but a wider reef. Do you want to talk a little bit about that before we show it?
Sure. So what's super important about, I guess not super important, but super valuable about using this technology that Kitty was talking about, combining technology and art and science, is we can use this to monitor a whole bunch of different things. We don't have to just look at how the corals are dying or one coral is dying. We can look at how an entire reef of corals are dying. Or we could look at how great they're doing.
Or not dying.
Or not dying.
How they're growing, or how there's more corals that are recruiting there, or just whatever you want to learn. If there's more algae on the reef or more sponges, we can build these gigantic models of an entire area of reef. So this is a reef that's offshore. This is what's called a mesophotic reef, and this is very deep. This is at about 125 feet underwater, and down there there's not a lot of light. So you see a lot of these corals are really flat compared to what we see on the shallow reefs, and that's that they can get as much light as they can. And it's cool here, you can see there's a lot of coral on this reef, and you can tell how well each of them are doing, or you can measure how big they are, or what species are there, what algae are there. You can ask a lot of different questions about reefs using these larger 3D models. And that's really important because these models are relatively quick to build based on your time in the water, because it would take so much longer for people to go through and take notes on all of these corals by hand than for us to just take the video to build this model and take the notes on the computer, where we're not limited by how much air is in our tank.
Right. So, another really cool part of this is, Sonora has been talking about, the diving and going down there, but this is a pretty deep reef. The mesophotic range, starts at 100 and something.
Yeah.
Yeah. So mesophotic is deeper than 100 and something. Don't worry, guys.
I think that's the technical definition is deeper than 100 and something. Yes.
Yes.
The scientists use 30 meters.
All right, so deeper than 30 meters, and that is, work on divers and resources. And so to be able to go down and get this footage, these planes, so many people want to come and leave. So, for a few divers to get this footage and make this model, and then imagine how many different scientists and researchers could utilize this to learn different things. So not only is it super cool, it's responsible too, because we're learning more and using the same resources.
Right, exactly, Kitty. The using the latest in technology to learn things that we could never possibly hope to understand before without this technology. We do have a question from the audience. Marilyn would like to know what can people do to help the corals?
Yeah.
And I'll open it up to anyone over there.
Yeah, so as we mentioned earlier, we have divers for the strike teams going down and giving medicine to the corals to help them fight off this disease. And that's one of the main ways we're working right now to help the corals. Another way that we're trying to figure out is how we can make the corals stronger. So rather than just giving medicine to sick corals, we want to figure out how to make the corals that aren't sick yet not get sick. And we're trying to do that with what are called probiotics.
Ooh.
And this is essentially just good bacteria. So this works in humans too. If you've ever taken probiotics as a pill or eat yogurt or kimchi or anything what's called live culture, if you put good bacteria in your body, they help you be healthy and fight off sickness. So we're trying to help the coral do this as well with stony coral tissue loss disease.
So those are things that scientists can do, but I'm going to pan over to people like me and Mason. What can we do to help the coral reef? So for those of us who are not actively in the water and doing this research and treating the corals, what we want to do is make sure that the corals have their best chance at being healthy. And a lot of that starts right up here with our everyday choices. So as I said, that Sonora took a drink out of her reusable water bottle, and I have my coffee in my oh wait, hold on. Oh geez, I'm too awkward. In my Reef Responsible coffee cup. Nice little Reef Responsible plug right there for Fish and Wildlife. So by using these, we are reducing our single-use plastics, reducing our chance of creating waste. Also, if you are building, you want to make sure that you don't have a lot of runoff coming off of your land and into the water. So pretty much just giving the corals their best chance at a healthy life.
Yeah. You need to help these corals both in the water and out of the water so they can be as strong as they can.
Yeah.
Right. I would agree with all of that. Everything that we're doing on land affects what happens in the water, even if we don't see it immediately. The other thing I'll point out is if you are in the water and you see a coral that maybe doesn't look super healthy, or you're just not sure, maybe you saw Science Saturday and you're not sure if it's bleaching or if it's disease, and you see something weird, that website that we mentioned earlier, vicoraldisease.org, has a way that you can actually send a photo or just even a verbal report to scientists to take a look at an area, take a closer look and see what might be going on the reef. So if you're ever out in the water and you see something you want to report, or as Kitty always reminds me, optimism is just as important. If you ever see a great looking coral, you say, I'm so excited to see this giant, happy, healthy brain coral, send that in too. We love seeing stuff like that.
Just to kind of bounce off of those happy, healthy corals you're finding, those are super important, like Joe was saying, because we can see if those are super strong corals that we can use to make more strong corals. So the way we can do this is we can study them and see what makes them strong, or we can take little pieces of them and start growing them in our laboratory where they have not a lot of stress, and we can make them as strong as we can, and we can put them back onto the reef to keep growing and remake that reef that maybe died from the not as strong corals.
Super. All right. Well, we are coming up on an hour now. It's amazing how long you can talk about the joys of coral disease and recovery from coral disease to keep it positive. Joe, do we have any last closing words, questions, comments, anything?
I'm not seeing anything from the audience. We'll wait a little bit of time, just remembering that we are on a slight delay.
Yes.
But I think just following your point, Kitty, I believe either this upcoming Science Saturday or the Saturday following, we're going to get a little bit more into what we are doing in response to this disease. Now that we've learned a lot about what the scientists and the researchers are doing, hopefully maybe next Science Saturday. If not, I'm sure very soon. But I'm not seeing any other questions right now. Were there any closing thoughts that you guys wanted to send out to the audience before we close things up?
Well, as always, I want to thank everyone for watching, but really, I'm going to step out. You know what? I'm going to turn around because what I do would not be possible without these guys, my hosts, my friends, my nephew, my intern. It is because of the work that is being done in the community that we are able to keep coming up with really fun Science Saturday topics. And on that note, since we have gone into this virtual hybrid model, if you are in the territory and working on a research project, have a really cool topic, and you want to host Science Saturday, especially if it requires me traveling somewhere really fun like St. John or St. Croix, please let me know. We want to know what's going on in the territory. We're so lucky to have the amazing resource at UVI. And we can always talk to more people. But we've got the UVI St. Croix campus. We have organizations. We have so much amazing stuff going on in the territory. We want to know about it. We want to teach about it. I want to learn about it because this is so much fun. So once again, thank you everyone for coming to Science Saturday, and I hope you have a wonderful day, wonderful weekend, happy President's Day, and happy Valentine's Day. Love you all. Bye.